Let's discuss the derivatives of trig functions. Let's start with sine x. So the derivative of sine x is equal to cosine x. The derivative of cosine x is equal to negative sine x. The derivative of tangent x is equal to negative secant, not negative, just secant squared x. The derivative of cotangent x, this one is equal to negative cosecant squared x. The derivative of secant x is equal to secant x multiplied by tangent x. And the derivative of cosecant x is equal to negative cosecant x cotangent x. So these are all the 6 trig functions: sine, cosine, tangent, and cotangent, secant, and cosecant. Now let's try an example. Let's try to find the second derivative of y is equal to secant x. And we know that the first derivative, y prime, is equal to, right here, secant x tangent x. So the first y prime is just secant x tangent x. But we want to find the second derivative. So the second derivative, this is the notation y double prime, is equal to the derivative d over dx of secant x tangent x. And we know from rules of differentiation that this is just uv, right? This is just y is equal to uv, and y prime is equal to u dv over dx, which is the derivative of v, plus v du over dx. This is used when you're multiplying two functions such as these, secant x and tangent x, together. So u and v, u is secant x, and v is tangent x in this case. So let's keep that in mind as we're going through this example. So this is u, and this is v. So the rule says that it's u multiplied by the derivative of v. So u, we can just write secant x multiplied by the derivative of tangent x, which is secant squared x, plus v, which is just tangent x, multiplied by the derivative of secant x, which is secant x tangent x. Secant x tangent x. So when you multiply these together and you combine and simplify, you get secant cubed x plus secant x tangent squared x. And that's the answer.